Noir Plasma Chrome Bleed. Unlocking knowledge, inspiring innovation, empowering curious minds.
This website makes learning so easy. I found all my resources here.
Like what you share.
Hey everyone, let's dive right into this incredibly fascinating breakdown of how modern operations have evolved into a living, breathing, cyber-physical organism. Welcome to today's Explainer, where we're going to take a really complex, vertically integrated strategic discipline, operations and systems optimization, and break it down into a clear architectural blueprint.
We've got a great agenda today, covering 6 key areas. We're going to start with theoretical foundations, move into cyber-physical LSS 4.0, explore multivariate statistical control, discuss quantitative project governance, examine the cybernetic loop, and finally, look at our implementation strategy. Let's get right to it.
Section 1. Theoretical Foundations of Data-Driven Operations Management. So, to understand why you can't just buy expensive data infrastructure and expect instant success, we first have to look at the academic theories that explain how successful operations actually function. It's kind of like a giant puzzle. If you look at the resource-based view, raw, tangible assets like servers and software just aren't enough on their own, right? I mean, anyone can buy those. They have to be transformed by dynamic capabilities so you can actually sense and pivot during market volatility. Plus, based on organizational information processing theory and contingency theory, you absolutely have to balance your processing capacity with real-world uncertainty, ensuring your setup actually fits your specific context. It's this exact combination of raw infrastructure, human analytical talent, and cultural alignment that creates a truly unbeatable competitive advantage.
And that brings us to a crucial warning. You might be wondering, can you have too much data power? Well, yes. If you don't match your data capacity to your real-world needs, you hit what's called the analytics capability paradox. You're basically over-investing in complex platforms when things are actually pretty stable. And instead of speeding things up, it introduces operational noise and administrative drag. It literally slows your entire organization down.
All right, moving on to Section 2, Cyber-Physical Lean Six Sigma or LSS 4.0 frameworks. Let's head down to the factory floor and see how these dynamic capabilities completely transform traditional Lean Six Sigma.
The contrast between the old way and the new way is honestly day and night. Traditional methods relied on periodic, manual data collection, which is basically trying to drive your business while looking in the rearview mirror. LSS 4.0, though, replaces human sampling bias with continuous, automated telemetry. We're talking about embedding IoT sensors and cyber-physical systems right into the machinery for real-time, machine learning-driven feedback.
What this means is that every single step of the classic DMAIC pipeline, define, measure, analyze, improve, and control, gets upgraded into a computational workflow. Take the improve phase, for example. Instead of disrupting the actual production line to run physical experiments, engineers now use virtual digital twins to test operational tweaks completely safely. It is a total paradigm shift. Which brings us to Section 3, Multivariate Statistical Process Control, focusing on Hodion-Helling's T-squared statistic. See, as we automate the analyze and control phases, those simple, single-variable charts completely fall apart. They just can't capture the complex relationships between multiple machine parameters.
Now, don't let the underlying math intimidate you. The concept is brilliant. If you evaluate correlated quality parameters using independent charts, you're going to distort your error rates and trigger massive false alarms. Hodling's T-squared statistics solves this by measuring what's called the standardized Mahalanobis distance.
Basically, this evaluates the true distance of correlated variables operating as a single unit in multidimensional space. It catches the hidden process shifts without all those annoying false alarms. So, what does this look like in practice? When the system calculates that t squared is greater than the upper control limit, it spots an anomaly. But it doesn't just blare a generic, unhelpful alarm. Automated decomposition techniques instantly step in to mathematically break down that aggregate value and pinpoint exactly which individual sensor is driving the failure. It's incredibly precise. Let's zoom out a bit for Section 4, Quantitative Project Management Governance. We're moving up from the factory floor to the enterprise level. This is where we track the timelines and capital allocations that keep the whole ship afloat. Here's a critical takeaway. Traditional earned value management, or EVM, has a massive fatal flaw. Its schedule metric is based on cost. Actually, let me explain why that's so bad. As a delayed project nears its end, the budget gets eaten up and the variance falsely trends towards zero. It literally tricks you into thinking you're back on track. Earned schedule theory fixes this mathematical illusion by mapping cumulative earned value directly onto the time axis. By tracking exactly how much time you actually earned versus the time you spent, project managers get completely unbiased forecasts. If your earned schedule is less than your actual time, your project is officially delayed, period. You suddenly have absolute mathematical certainty on when a project will actually finish. Now pay close attention to this number, 1.10. In earned schedule theory, if your toe-to-complete schedule performance index hits 1.10, the math proves your project's recovery is statistically unachievable. Without major scope cuts or massive resource dumps, you are not hitting that target. It completely takes the emotion and the hero complex out of project recovery. Earned schedule also gives us the P factor. It's essentially an auditor for team discipline. It flags executives when teams are artificially inflating their progress by burning effort on the easy, out-of-sequence tasks, while the really difficult, critical tasks are completely stalled out. Moving right along to Section 5, Mixed Integer Linear Programming for Portfolio Selection. Knowing how individual projects are doing is great, but what happens when you have dozens of complex projects running at once? That's where Mixed Integer Linear Programming, or MILP, comes in. Think of it like a master puzzle solver for your capital. It maximizes your expected financial returns, your overall net present value, while managing your risk tolerance. And the best part? It does all this while strictly navigating hard operational constraints, like budget limits in a quarter or rules dictating that Project A absolutely has to finish before Project B can even start. And now for the really fun part. Section 6, the operational cybernetic loop. Let's see how all of this builds into an ultimate, self-correcting organism by wiring everything we've talked about together. This is where the magic really happens. Imagine this scenario. An IoT sensor on a machine detects a baseline anomaly. That data instantly flows into the Hot-Telling's t-squared analytics, calculating a process delay. That exact delay dynamically updates the earned schedule metrics, which recalculates the project's timeline. That timeline shift then triggers the MILP engine to reallocate the portfolio budget. And finally, it transmits updated operational targets right back down to the factory edge controllers. The whole shebang is a completely continuous, fully automated feedback loop. Finally, let's wrap up with strategic synthesis and implementation governance. Because let's be real, you can't just buy a bunch of software and expect this architecture to build itself. You have to build it from the data pipes up. Standardize the industrial IoT pipelines first to kill the silos. Then transition to Hot-Telling's t-squared statistics and machine learning. From there, upgrade your enterprise monitoring to earned schedule theory and enable that dynamic portfolio rebalancing. But consider this last crucial step. Cultivate a data-driven culture. None of this math matters if your people don't actually trust the analytics over their own traditional gut feelings. And that leaves us with a truly profound final question. As these cyber-physical systems get better and better at sensing, seizing, and governing themselves, reallocating capital and fixing factory errors in mere milliseconds, where exactly does the human executive fit in? Will we just be observers of the mathematical models we built, or will human intuition find a brand new, higher-level purpose in the enterprise of the future? Definitely something to think about. Thanks for tuning into today's Explainer.
Like what you share.
This website makes learning so easy. I found all my resources here.
Noir Plasma Chrome Bleed. Unlocking knowledge, inspiring innovation, empowering curious mind.